Hello, can you hear me? Hello, guys, can you hear me now?
Yeah.
Yes, we can hear you.
Yes.
Okay. So today I couldn't make it to the campus, so I decided that instead of not having the class at all, let us have it in Zoom. This week we're entering a new topic. Before we move into that, I want to show you a few things in the course website. In the course shell, I mean to say. Just give me 1 minute. Let me pull it up. Okay. All right. This is the announcement I have for week 9. We are now in week 9. So week 9, we will begin chapter 5 and 6. We covered chapter 5 and 6. And then after that, we now move on to the. Hopefully, we finish both of them next week. Hopefully. And so far, the only assignment that is due this week is homework 6. But I made it available until November the 2nd, so you have more time. And then, of course, you can access it by going to the models. Scroll down to model 4, and this is where you see. I want you to see this table here. I want you to download it and print it. We'll be using it from now on. I have a sample of it here. I call it the statistical table. It's right here. We can, keep it handy because some of the homework questions and even some classwork, you need this table. So I'm going to close this. I hope you saw him. So you are seeing this. Okay, good, excellent. So I want to print it. Now that I've shown you the table, I can now close it. We're not going to use it today, but next week we'll start using it. So download it and print it, keep it handy. And like I said, this is homework. When you click on this, it will take you to my lab and mastering, where you can begin the homework if you choose to start early. Now let us begin. We're looking at what is called probability distributions. Today we'll be focusing more on the discrete probability distribution. Discrete probability distribution. So let us begin by exploring the basic concept. Let's start with random variable. Now, a random variable simply means a variable whose values, that the values are determined by chance. For example, if you toss a dice, the outcome can be 1 showing up, 2 showing up, 3 showing up. Can be any outcome that you have no control over it. So they are determined by chance. Now, how about this? The time a bus arrives at a bus stop. They might say that it might arrive at 8 a.m., but we know that sometimes it arrives a little bit before or a little bit after. And sometimes even late. It might arrive very late sometimes. So that's to give you an example of a random variable. How about this? Number of students that any of you have, number of siblings that any of you in the class have. To me, I have no control over that. To your classmates, they don't have control over that. It's a random variable to us. To you, it's not, but to us, it's a random variable. So to every other person but you, the number of siblings you have is a random variable. I think you get the point. So now we're looking at the discrete random variables. Discrete random variable. Now, a discrete random variable uh, is a random variable that have finite or infinite number of possible values that can be counted. So that's what it makes them unique. They have values that can be counted. So, for example, if you go to Patterson Park in Baltimore City, you can how many people that are taking a jogging? You can count them. You can say one person is jogging, or 20 people were jogging. You can never say 1.5 person or 2.5 person are jogging. Say they are countable. We call them discrete because of that. How about number of eggs a hen lays in 1 week? 1 egg, 2 eggs, 3 eggs. You cannot say 1.5 eggs. So they are countable. How about number of telephone calls you received after a TV commercial? 1 call, 2 call, 3 calls, no calls. You can say 5.5 calls or 1.5 calls. Never. So that's why we call them um, discrete random variables. Now, for continuous random variables, the variables are obtained from the data that can be measured. Data you can measure. So things like height, temperature, voltage, you can measure them. So they are not countable. They can be measured. We call them um, continuous random variable. Now, our focus today and on Thursday that's coming will be on the discrete random the probability distribution that focus on discrete random variables. We call it discrete probability distribution. A discrete probability distribution consists of the values a random variable can assume and the corresponding probability. The values they can assume and the corresponding probability. That's why we call it discrete. We have many types. We have the binomial distribution, we have the Poisson distribution, and the hypogeometric distribution. We'll come to that. We'll be focused more on binomial and Poisson distribution. Yeah. Now, we also have a continuous probability distribution. Those ones like normal distribution, uniform distribution, and exponential distribution. Our focus will be more on the normal distribution and the uniform distribution. We're not going to do those ones this week, but the next week. Now let's start with the discrete probability distributions. So this is the one that describe the values a random variable can have and the corresponding probabilities. So let's do some practical example questions or solve some practical questions on that reflect this. Let me see if I can make this okay. Make this okay. Yeah, let me see. Okay. Look at this question. It says make it 18. It says construct a probability distribution for rolling a single dice. Actually, a single dice. Right. See, it's a die or dice called. You can see the dice right here. So knowing that this kind of distribution involve the outcome and the probability of those outcomes, you make a table like this. Right? The outcome X and the corresponding probability, which is the PX. Knowing that this dice has how many sides? 6 sides. The first side there's the side that have 1 written on it. There is a side that have two dots, 3, 4, 5 on them. So each of them have 1 out of 6 chances because for a dice, 6 side, the probability of any of the side showing up when it is tossed is 1 out of 6. For each of them, 1 out of 6. Okay? 1 out of 6. 1 out of 6. 1 out of 6. 1 out of 6. Okay? So this is it. That is the probability distribution. So see the outcomes and their corresponding probability. Does anybody have a question on this? Any question, guys? Yeah, excellent. No question. Good. Now, let's look at another example. Here, it says that during the summer months, make it 80 as well. I mean 18 as well. He said that during the summer months, BMZ Rentals Incorporated is a rental agency. And it keeps track of the number of chainsaws it rents each day during the period of 90 days. So the number of saws BMZ rented per day is represented here by the variable X. And the result are shown here. It says, can see the number of saws rented as X. No saws was rented in 45 days. One saw was rented in 30 days, 2 in 15 days. It says, compute PX for each X. That means calculate the probability for each of the X's here. And it says, construct a probability distribution and graph the data. So let's start with making this. First of all, let's make the table. I'm going to copy this. So we can make the table. Okay. Now move this down so we can have enough room. All right. And then we can insert we need this number of days and the PX. Total of days, let me write this down. We need number of days, and we need one column. We need to insert one column there, which is the P for the probability of X. So I insert it here. It's a PX table. PX. Okay. So now we need to calculate the probability for each of the 0, 1, 2. But if you need to get the total here, let me write these numbers down so you can get the total. We got 45, we got 30, we got 15. Okay. All right. So let's go and add this in the calculator. Okay, where is our calculator? I know I have it somewhere. So I got 45 plus 30 plus 15. Give me 90. 90. Okay. So I'm going to put 90 right here. So let's calculate the individual probabilities. P of 0. Now I'm going to make this to be 80 again. P of 0 will be 45 over 90. So that we got 45 divided by 90, 0.50. 0.50. So I'm going to put it right here, 0.50. We'll put the same thing for P1, probability for 1, P1 will be equal to 30. For 1, number of days 30 is the rented once so in 30 days. It's 30. That is, for number of days they rented only one saw. It's 30. That means like for 30 days, we are just renting one sub a day for 30 days, 30 over 90. Go to our calculator and then get the result. Change this to 30.333, 0.333. Oh, we make it 33. Now for 2, have P2 will be equal to, for 2, we have 15. 15 divided by 90. So in that 15 divided by 90, I'll make it 15 here. 0.1666. So I'm going to round it 0.17, rounded. 0.17. Okay, so I'm going to put all of them here. 0.33, 0.17. So now we have because the question was saying construct px for each of x. I have them right here. So you can see the x and the corresponding probability of x. And it says construct a probability distribution and graph the data. Yep, right here. The outcome and the corresponding probability right here. So that is your probability distribution right there. Now to draw the graph, you can use this. Let me see if I can use this to draw the graph. I'm gonna do we got okay, that's a mistake. I got 0, 1, and 2. 0, 1, 2. And that is our px right there. I mean, I'm not the px. Number of day, sorry. X represents number of chainsaws rented. Okay. So I'm gonna have it number of chainsaws rented. I'm gonna draw a line right there. Oops, excuse me, sorry. Sorry, mistake. Number of chainsaws rented. Oh, a mistake again. So I'm gonna undo it. Number of chainsaws that are rented. Of course, make adjustment, a little bit, a little adjustment. Then, the PX, our probability is go from 0.17, 0.33, 0.5. So I'm gonna use here. Okay. 0.1, 0.2, okay, 0.3, 0.4, 0.5. Okay. So that's what I'm gonna use. So I'm gonna move this a little bit. So we have enough room here. Matter of fact, I'm gonna extend it. This one I'm gonna move. Then I'm gonna draw the vertical axis. Then this is our PX, probability we're looking for. PX, we have it already. PX. Okay. Now we're ready to draw graph. Okay. It says on 0 days rented 0.5. 0.5 should be around here. So I'm gonna draw the graph. Okay, for 0 days. Okay. I put it right here. 0 days. It's a line graph. I can make it a histogram anyway. So it's a line graph, and I'm gonna use this for 0. Start from 0. It's 0.5. Okay. Now for 1 day, it's 0.33. Look at 0.3 here. 0.3 is around here. So I'm gonna right here. Yeah, I'm not too good with drawing with the computer, but with a ruler and pencil, you can, do this. 0.33. And for 2 days, it's 0.17. This is 1. This is 2.2. Halfway is 0.15. So it's 0.17 should be around here. So I'm going to use this and draw it. Oh, excuse me. I got to make it on the 2. Okay. 0.17. Okay. Now, we can now close the gap to form the histogram. 0.5, so it's right here. Okay, 0.3. I'm drawing a little bit sloppy, but yeah. Okay, let me see. Excuse me. Yep. And then this one, close it. 0.17 here. It's the mouse that is shifting a little bit. I got it. So that's the graph. There's a graph right here. First of all, we calculated the probability to get the probability distribution outcome and the corresponding probabilities. We calculated them here and we draw the graph. Answer the question. Any question on this class? Hello, can you hear me? Any question? Hello, guys, can you hear me?
Yeah, no
Yes, we can
question.
hear you.
No question.
Yeah,
Okay.
my fault. Yeah, we can hear you.
Okay, good. Okay, good. Now, which this brings us to the 2 requirements before we can call something a probability distribution. There's 2 requirements. First is that the sum of the probabilities of all the events in a sample space must equal 1. Now look at this for the first one we did right here. If you add all of them here, they have the same denominator. So 1, 1, 1, 1, 1, 1. So that's gonna be 6/6. So that means I'll put it this way: sum of px is 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. How many of them we have? 1, 2, 3, 4, 5, 6. We got 1, 2, 3, 4, 5. That's one more. 1/6. And that will be equals 6 out of 6, which give us 1. So this place is going to be 1. And if you look at the second one we did, if you add all the probabilities here, the sum of EPX will be 0.50 plus 0.33 plus 0.17. Okay. Let me write them down and then we can go and add them in the calculator. I got 0.50 plus 0.33 plus 0.17. When you go to our calculator, we can put this in. 0.50 plus 0.33 plus 0.17. 1. I see that it's 1. Answer gonna be 1.00. So that is what this rule is saying, that the sum of all the probabilities of all the events in the sample space must equal 1. The other one was saying that the probability of each event in the sample space must be between or equal to 0 and 1, which means that the probability of an cannot be a negative number, and it cannot be a number greater than 1. Let us test this. Look at this question. It says, determine whether each distribution is a probability distribution. You can see the outcomes. You can see the corresponding probabilities right here, Px. So let us add and see if it satisfies any of the rules. So we got 1/5, 1/5 plus 1/5 plus 1/5 plus 1/5. How many of them? We have 1, 2, 3, 4, 5. 1, 2, 3, 4. One more. 1/5 equals 5/5 equals 1. So answer is yes. Yes. Because the sum of the probabilities, yeah, abilities, the sum of the probabilities equals 1. Okay, now let's test this one here. This one you don't even need to do anything, because remember this second rule. Second rule here say that this means that the probability of an event can never be a negative number, and it can never be a number that is greater than 1. So this one, we don't even need to do anything, because we have a negative probability right here, and we have a number here greater than 1. So answer now becomes, no, it is not a probability distribution. Because one of the probability values is negative, and another one is greater than 1. Okay, so can you look at this one? It says, let's try, say this one have, and make it big. Okay, make it 18. It has x and px. So in that way, let's add 1/4 plus 1/8 plus 1/16 plus 9/16. Let me write this down so we can add them. 1/4 plus 1/16 plus sorry, 1 over 4 plus 1 over 8 plus 1 over 16 plus 9 over 16. So let's go and add this. Okay? See if it gives us 1 or not. So I got 1 divided by 4 plus 1 over 8 plus 1 over 16 plus 9 over 16. 1. You can see it gives us 1. So the answer is 1 and this yes. 1. So it's yes. Yes. Because the sum of the probabilities equals 1. So you can try this one as a practice at home. Any question on this example? Okay, no question. Good. Excellent. Excellent. Now, I might ask you a question that is similar to this one. Like this, it says, determine the required or the missing value of B to make the distribution a discrete probability distribution. So you can see they give you the outcome and the corresponding probabilities, but this one is this probability is missing here. So the answer they want to determine what the outcome will be. Now, based on the fact that you know that the sum of this should be 1, all you have to do is to subtract all this number from 1. So now the B becomes 1. This here. So 18. 1 minus 0.41 plus 0.02 plus 0.35. That will give you an answer right away. Write it down. 1 minus 0.41 plus 0.02 plus 0.35. So let's do it on the calculator. 1 minus 0.41, 0.02 plus 0.35, 0.22, 0.22. Okay. So now I have given you a background information on what a probability distribution is. I mean, a discrete probability distribution is. First of all, I started with the meaning of a probability distribution, and I explained the discrete and the continuous probability distributions. And I'm giving you a background on what a discrete probability distribution is and the properties, some of the properties. Now let us go to the application here. Let's see how to find the mean, variance, and standard deviation of a probability distribution. Remember, we have done the mean, variance, and standard deviation before at the beginning of this class, but we did it for a frequency distribution. Now we are doing it for a probability distribution. So even though they are the same mean and variance, but the formula now is different because we are now factoring in probabilities. So for the mean is the sum of x times px. And variance is, which is the delta square, is sum of x squared times px minus the mean squared. Then the standard deviation is always the square root of variance. Let's look at these applications here. It says Davis Williams is the president of the Middle River Community Bank. Mr. Williams feels that each savings account customer has on average 3 credit cards. The following distribution represents the number of credit cards people own. You can see number of credit cards, no credit card. This is the probability here, 1, this is the PX, 2, all the way to 4. But he's claiming that each, make this 18. He's claiming that each credit savings account customer has on average 3 credit cards. That was his claim. So he says, find the mean, variance, and standard deviation. B, is Mr. Williams correct in his claim? Well, let's find out. First of all, let's just find the mean. To find the mean, variance, and standard deviation, we make a chart like this one. A table, not a chart, a table. Where we have the outcome, which is number of credit card on this side, and the required probability on that side. Then we need to find this column, and that column. This one is x times px. That means this times that. So 0 times 0.18 is 0.00. 1 times 0.44 is 0.44. So we follow that process to get the rest of this. 2 times 0.27 will be, let's get it on the calculator. So you got 2 times 0.27, you got 0.54, 0.54. As a matter of fact, I think I solved this thing somewhere before. So because unless you know the concept to apply those two sides, and then you have your results. So you're just multiplying x times px. So I think I solved this somewhere. So to save time for us. Yes, I think I did. I believe I did. No, I got it. Got it. It is right here. So I got the rest of them. So as for 0.08, we got 0.24. And for this one, we got 1.20. 0.12, I mean to say. Now, x squared, just to square this one. 0 square is always 0. 1 square is always 1. 2 square means 2 times 2, which is 4. 3 square is 9. 4 square is 16. So we need this one so that we can be able to get this one here. X squared times px. So x squared, we use it to multiply px. So 0 times 0.18 give us 0.00. 1 times 0.44 is 0.44. 4 times 0.27 I got. 4 times 0.27 I got 1.08. And then 9 times 0.08 I got 0.72. Okay. Then 16 times 0.03 I got 0.48. So if I add all this one here, you're gonna get 2.72. You can verify it with your calculator. And if you add all this, you're gonna get 1.34. So these are the two totals we need. So now sum of x times px is this one, which is 1 point. That's the mean. Mean is, remember they asked to find the mean, variance, and the standard deviation. So sum of x times px, this is x times px. This is sum 1.34. 1.34, which is basically 1. one credit card, which is basically one credit card. One credit card. Yep. Variance is x squared times x minus b squared, which is gonna be, make this in to be 16 or 18 even. Which is gonna be, yep, equals, this x squared times px, right? It's right here, 2.72 minus the mean. We got the mean as 1.34. 0.34. And it says square it. So we gotta square it. 1.34 squared. And that will give us the variance right here. So I'm gonna write this down. I'm gonna make this equal 18. So we gotta write this at my paper. I got 2.72 minus 1.34 squared. Going to our calculator, have 2.72. 2.72 minus 1.34, squared, 0.9244. Basically 0.92, 0.92, 0.92. So, and then the standard deviation will be square root of variance. I didn't get I'm gonna get the formula here, right here. The square root of variance. So it's gonna be square root of variance should be square root of this number here. Square root of I don't have it. So let me get it from the I have the variance as 0.92, square root of 0.92. Let me go and get it from the other workbook. Don't have it, so I'm gonna open it. Okay, share this. So we have the square root of standard deviation. Let me call it excuse me, a mistake. Standard deviation equals the square root of variance. We have variance at 0.92. Okay, equal. Let me make this big. 18, probably 18. Okay. Now I can go to the calculator. Square root of 0.92, 0.96 rounded, 0.96 rounded, 0.96. Okay. I'm gonna copy this. I'm gonna paste it in the main workbook. Okay, this is our standard deviation right here. So we have answered the three questions. They say mean, variance, and standard deviation. Now the last question is that is Mr. Williams correct? Of course, it's not correct because his claim was that each savings account customer has on average three credit cards. But from this from our work here, you can see that the mean, which is the average, is 1.35, which is one credit card. So he's not correct. So the answer is no. because um each of the someone just came in. Okay. Each of the, I would say, because his claim was that okay. His claim was that each of the um savings account customers have an average three credit cards. So claim is incorrect because each of the savings account customers has on average one credit card, not three. One credit card they have. So each of these customers has only one credit card, not three. He claimed that they have three. They don't have three, they have one. Any question on this? Any query? Any question?
No, sir.
Very good, excellent. Now, so you can see the application, how to apply it. Now, let us look at another application. We call it the expected value. Um, expected value. So we have the, let's start with the definition of expectation. So expectation is seen, like I say, it's called the expected value of a random variable. Is the theoretical average of the variable. That's the average of the variable. That's the expectation, expected value. I can call it expectation, which explains why we use the same formula we use for the mean here, that the expected value of x equals sum of x times the probability of x. Okay. Now let us apply it. Can apply it in so many things. In lottery, um, in so a lot of things, as a matter of fact. Business. Uh, so let's do it. It says a lottery has at Mount Carmel's Catholic Church annual bazaar offers one $1,000 prize, one $500 prize, and five $100 prizes. Okay. So 1,000 tickets are sold at $3 each. Find the expectation if a person buys one ticket and if the winning ticket is returned to the pool after each draw. Okay. So in this case, we have a different scenario. This is a lottery. So you have the probability of winning and probability of loss. And that, excuse me. So you have we have win. So of course, if you buy one ticket to win, your ticket will show up after from 1,000 tickets. So fear of win is 1 out of 1,000. Since if the ticket is returned to the pool, it's 1 out of 1,000. So so you have one out of it. Let me make this make it 18. So 1 out of 1,000 will be yeah, 1 divided by 1,000 is 0.01. So that's 0.001, I believe. Yeah, 0.001. Now the probability of losing, that will be the complement. You might be tempted to say 1 minus 0.001, but that's not the case because remember we have how many prizes? You have one $1,000 prize, one $500 prize, then $500 prize. So if each of them have 0.001 of winning. So you have to factor that in. So you're gonna be we have anyway, we have the complement now becomes not winning those prizes. I'm gonna be 1 minus for the $1,000 prize 0.001 plus for the $500 prize, which is one of them, 0.001 plus, excuse me, for the $500 prize, there are 5 of them. So you gotta do it 5 times. 0.001, 0.001, 0.001. It's 3 of them now. We make that section to be 16. So we'll have enough from there. So this is 1, 2, 3. 2 more. Plus 0.001. Okay? That will give you the probability of losing. That means probability of not winning the $1,000 prize. They are not winning the $500 prize and not winning the $100 prize 5 times. So that's 1, 2, 3, 4, 5. So that's gonna be. Let me write this. We're gonna do it for a calculator. That'll be easy to put because they are the same probability. So we have cleared. We have 1 minus 0.001 for the $1,000 prize. 0.001 for the $500 prize. Then five different probabilities for the $100 prizes. So I have 1, 2, 3, 4, 5. So answer is 0.993. 0.993. 0.993 is the probability of losing. Now with this, we can now form our table so that I can find, because you see, the question was find the expectation. That means find the theoretical average. Okay? If the person buys 1 ticket and if the winning ticket is returned to the pool. Now, so to be able to find the average, we need to find to make a table like this: win x, then the probability of x, and then s times px, which will help us to find the average. Now, there's nothing you need to understand, which is that suppose you buy the ticket for $3 and you won $1,000. They'll give you $1,000, sure, but they will not give you the $3 you paid for the ticket. So even though they give you $1,000, your net gain is 997 because you got to subtract the $3 from the weight. So for the $1,000, we have 997. That's a net gain. So in a similar vein, 500 will be 497. And the $100 price, if you win them, your net gain is 97. 97. 97. 97. 97. Now, how many? 1, 2, 3, 4, 5. Now, of course, another thing is $3. Most of the time you lose anyway. So if you don't win any of these prizes, you lose $3, which can be -3. -3. Now, the required probabilities for each of them is 0.001 for this, 0.001, 0.001, 0.001, 0.001, 0.001. Okay. Now for loss, you have 0.993. That means you have 99.3% chance of losing. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3%. 99.3% in lottery game. That's why they call it lottery. Anyway, have this. Now let us get the x times px. So 997 times 0.001. Let's do a calculator. We got 997 and 0.001. Give us 0.997. 0. And if you follow that method, you're going to get the rest of them. I have them here on paper. I got 0.497. I got 0.097. Then for the last one, -3, I'm gonna write it in paper. -3 times 0.993. So -3 times 0.993 is negative 2.979. Negative 2.979. Now let us find. Well, remember the question was to find the expectation if a person buys one ticket. So that means to find the theoretical average. So that you need to. The average is sum of x times px. That means you add all this. I'm gonna write this down on paper so I can add them. Calculator. 0.997, 0.497, 0.097, 0.097. Okay, 5 of them. Last one is negative 2.979. Let's go and put them in. So we got 0.997, 0.997 plus 0.497 plus 0.097 plus 0.097, 0.097. Okay. 302. Okay. Plus 0.097 plus that 1, 2, 3, 4. One more. Then plus negative 2.979. It was -1, which represents a loss. -1. So in most lottery, -1.000. So that the expected value is -$1. So most lotteries, you are winning. I mean, you are losing. I mean, some people win now and then, but if you check if they ask them how many times they've lost, you see that unless you win the jackpot, otherwise you are most of the time you are losing. Any question on this? Okay, no question. Good. Now let's do the last one. Let's use to round up. When we apply this to business, it says a ski resort located in Cleveland loses $70,000 per season when it does not snow very much, and makes $250,000 profit when it does snow a lot. The probability that it will snow at least 75 inches, which is snowing a lot, in Cleveland is 40%. You can get this from the weather forecast. Find the expectation for the profit So this ski resort, the profit depends on the quantity of snow. If it snow a lot, they make money. People like to go to ski. I don't know what it's called, skiing or skiing. You guys speak
It's skiing. It's skiing.
skiing, okay, okay. So let's say if it is a profitable business for this company, given that they have the 40% probability. So if this snows a lot, profit will be 250,000 to 250,000 here. And if it doesn't snow a lot, they lose money. They lose 70,000. That's kind of going negative 70,000. Okay. Now, the probability they say is 40%, which is 0.4, which means that the probability that it doesn't snow a lot will be 0.6. Now, how do I get 0.6? 1 minus 0.4 will give you 0.6. Now, S times PS, 250,000 times 0.4. We got 250,000 times 0.4 is 100,000. 100,000. Now, if it doesn't snow a lot, you can have negative 70,000 times 0.6. So you're going to be negative 70,000 times 0.6. Negative 42,000. Negative 42,000. So the total now becomes, which is the average, becomes, you add this two. So 100,000, 100 times, plus negative 42,000 give us 58,000, which is positive. So it's a good business. If it's negative, it's a bad business. 52, what's the amount again? Hold on. It is 58,000. So it's a good business. It's positive. 58,000. So that the expected value now becomes sum of x times the.
Excuse me.
Yes, yes, ma'am.
How did you get 0.6?
Yeah, because it says 40% chance that it will snow at least 76 inches. The opposite is 60%, right? If it is 40% that it will have something will happen, then the opposite that will not happen will be 60%. I mean, it's 100 minus 40. 60%. That's how the 0.6 came.
Oh, okay.
So you've got $58,000, which is a profit. So it's a good business. So if it's negative, that means not good. Like lottery. Lottery is always not good because you lost. Most of the time you lose. It is skewed. If you remember when we did skewness, it is skewed to favor the house. Always. Otherwise they won't be in business. So any question before we round up? We are done for today. Any question? No question. Good. Excellent. So on Thursday, we begin from binomial distribution. And I see you guys on Thursday. You have a nice day. Can you hear me, guys?
You as well. Thank you.
You too.
Okay, you're welcome. Have a nice day. All right. On Friday, on Thursday.